A set, okay. So quick mini lecture over 4.3. These are the same sorts of questions we've already seen, except for now they're all mixed together, okay? And our job, part of our job in this section of Unit 4 is to figure out which of these 5 equations we're going to use. So that's what we're going to focus on in our lecture today, in our review of this. I'm not going to really harp on sorting out and finding all the right answers. You can find out that information from other lectures. We're going to focus on step 1 of solving word problems. So we'll look at problem number 1 here. It says, while traveling along the highway, a driver speeds up, blah, blah, blah. What is the car's acceleration? So the thing we need to know for this problem is which equation to use. And we're going to use our acceleration equation. Okay? The acceleration equation is A equals VF minus VI over T. And then we're going to go in, we're going to find the values from the problem, and we're going to punch that in. Okay? For VI, we're going to use 20 because that's the earlier speed, the earlier velocity we was talking about. For VF, we're going to use 24 because that's the velocity that happens later. And for T, we're going to use 2. So we're going to take these, we're going to punch them into the equation and solve. And that's how we find acceleration. For problem number 2, it says Lexi walked for 4 hours at a speed of 2 miles per hour. How far did she walk? What we are looking for here is how far. This is going to be distance. So we use our distance formula, D equals V times T. And then we go into the problem and we find the values from the problem and punch it in there to do step 2. So speed is V. Speed and velocity are interchangeable in these calculations. All the ones I've had to do anyway. So 2 miles per hour goes in where V is, and 4 hours goes in where T is. And then we have D equals 2 times 4. So problem number 3 is also, we'll get into that in a second. Problem number 3 is a problem. It says a car traveling at a velocity of 60 meters per second encounters an emergency, comes to a complete stop. How much time will it take? How much time will it take? How much time? This tells us that we're going to use our T equation. The thing is, we have 2 T equations. If we go to the top of the page, we can see both of them. Okay, I know I got them all covered up and stuff. But here I have T equals V over V, and here I have T equals VF minus VI over A. Well, get down here to problem 3, and we'll see. It's asking, how much time will it take for the car to stop? How much time will it take for deceleration to occur? Okay. In other words, if it gives us a starting speed and a final speed, then we're going to use T equals VF minus VI over A. Now, if it had given us the distance and the velocity, we would use the T equals V over V equation. But we're not going to use that one because that's not the values it gave us. It didn't give us distance or velocity. Okay? It gave us 2 velocities, but it didn't give us a change in velocity. So we're going to use T equals VF minus VI over A. And to find these values, again, we're going to take these from the problem, from the words, and we're going to put them into the equation. So 60 meters per second, that's going to be our VI. It comes to a complete stop. Stop is going to be VF, that's our final velocity. And the acceleration is actually a deceleration. And that deceleration is going to be -5.
Yeah.
-5. So then we take these values, -5 goes in here, 60 goes in here, and stop, which is 0,
Oh man.
goes in here. Okay? And that's how we solve to find the time interval of acceleration. The time interval of acceleration.
Right. Yeah.
Problem number 4. It says a car going down an incline for 12 seconds has an acceleration of 4. If it has an initial velocity of 2, what is its final velocity? We're finding final velocity. We're going to use our VF equation. VF equals VI plus, and I put this term in parentheses, but it doesn't have to be. We would get up to the same thing. A times T. We go to the problem, we identify what VI is. It has an initial velocity of 2, so that's VI. Okay. The acceleration is 4, and the time is, oh, sorry, I'm pushing some of my zoom up here. The time is 12. So we take these values, we punch them in the equation. 4 goes here, 12 goes here, 2 goes here, 2 goes here, right? And we just take them from the problem, punch them in here. Okay. Problem 5, it again asks for acceleration. We already went over that, so I'm going to skip that. Problem 6 asks, what was her initial velocity? So we're going to use our VI equation here. VI equals VF minus the change in speed, A times T, minus the change of velocity. And then we're going to go in and we're going to grab these values from the problem. Well, VF was, by the time she gets to the top, her velocity is only 1. This is VF. Okay. Acceleration is going to be 2. And the time is going to be 4 seconds. We just grab those right from the problem. Question 7, again, asks for final velocity. We've already gone over one of those. Question 8 asks for Brett's velocity. Okay, Brett's velocity. It says, Brett walked 20 meters. It took him 4 seconds. What was his velocity? Velocity. We're going to use our velocity equation, which is the same as our speed equation. V equals D over T. Or sometimes you see me write this V equals D slash T. These mean the same thing. Okay. And again, we're going to go into our problem and we're going to grab the values from the problem. We're going to punch them into our equation. The distance, 20 meters. The time was 4 seconds. We'll take those and punch them in. And step 3 would be to put that in a calculator and solve. Problem number 9 is again a final velocity question. Problem number 10 is an initial velocity question. We can skip that. We've already gone over that. Problem number 11 shows us the other kind of time interval. No, actually shows us the first kind of time interval. Same one we talked about here. How much time will it take in problem number 3? So we need to skip that one. Problem number 12, though, gives us the time interval of travel, not the time interval of acceleration. So here we're figuring out not how long does it take the thing to speed up or slow down, we're figuring out how long does it take the thing to travel. How long does the thing move? Okay, we have 2 different kinds. I'm going to write them down here at the bottom. We have 2 different kinds of T equals equations. T equals D over V. And we also have T equals VF minus VI over A. And we have to decide, when it says how many days, is it asking how many days will it take the thing to speed up or to slow down? Oh, it doesn't give me a final velocity. It doesn't give me a final velocity, it doesn't give me an initial velocity, and it doesn't give me an acceleration. So if I want to know how long the story takes place, I need to look at what it does give me. Does it give me a distance? Well, here we go. We've got 45 miles. That's distance. Does it give me a velocity? Velocity? Here we go, 15 miles per day. speed it gives me. So if I want to know how long it's going to take me to get there, first of all, we're going to use our T equals D over V equation. Okay. And then we just divide the miles by the miles per day to find out how many days. We take 45 miles and put it here. That's the wrong color. Take 45 miles, we put it here. We take 15 miles per day, that's a speed, we put it here. And we punch it in the calculator, step 3, and we get our solution. We find out it takes 3 days to walk to Columbus if we can do 15 miles per day. 15 miles a day is fast walking, by the way. Doable, not easy. All right, problem number 3. It says John left home at 3. He walked at 3 miles per hour until 9 p.m. How far did he go? This is one of those 2-step problems we've talked about. So to start out with, we need to say, how far did he go? We need to use the equation. How far did he go? That's going to be our distance formula. D equals V times T. The distance equals the speed times how much time he traveled. And I can tell you right now that we need to solve and find T here. We need to find out how long John was walking. Well, if he walked from 3 p.m. to 9 p.m., we can do some math. 9 minus 3 equals 6. So we can take this and put it in here for T. Okay. And then we take the 3 miles per hour, that's the speed we have, and we punch it in here. So he went 3 miles per hour for 6 hours. He went 18 miles. This is how we solve each of the kinds of problems that are going to come up on the upcoming test. If anyone has any questions about these, I'd be happy to help you guys out in the chat, or you guys can get a hold of me by text or by email. And I'll be happy to clear these up for you.